In this video, we're going to look at question 1 from the slightly longer bonding and structure questions. Make sure you've had a go before we go through it. So we've got some questions about aluminium compounds, and the first bit is we're told aluminium fluoride is ionic. We're going to need to remember that when we do the dot and cross diagram, but first we just want a formula. So aluminium is in group 3, so we can assume it's going to make a 3+ ion, and fluorine is in group 7, so it's going to make a 1-. So the formula is going to be AlF3. Part 2, we now need to draw a dot and cross diagram. So when we're doing an ionic dot and cross diagram, I want to make sure we think of the particles as being separate from each other. So we're just showing what the ions look like. We're not trying to draw a molecule here. So we're not trying to keep them close together. Doesn't matter. Aluminium. It doesn't say about how many shells, like whether to include the inner shells, so I'm going to include the inner shells just in case. So it would be 2A3, and its ion is therefore 2 and then 8. And so I'm going to draw all the electrons in aluminium just to make sure. Fluoride is also going to make an ion with a configuration 2-8 because it starts 2-7 and gains 1. I'm going to put 2 in the inner shell. I'm going to do 7 crosses, and then I'm going to show my 1 electron having been gained to give it its full outer shell. Then we're going to include the charges. So at the moment we're probably about 1 out of 3 marks. Second mark is for including the relevant charges. Third mark is for balancing this diagram and showing the correct number of each ion. So I would have 3 lots of aluminium fluoride, fluoride ions. I don't want to put the 3 down low like it is in the formula, because that's not quite the same thing. So when aluminium reacts with chlorine, the compound formed is covalent. So drawing a dot and cross diagram to show the bonding in aluminium chloride means I now need to move to a covalent. The reason it's told you in this question is because, of course, aluminium is doing 2 different things with 2 different elements. So I'm going to draw the bonds first because every chlorine is going to need to share one with aluminium. Then I'm going to check for any extra electrons that need to be added. So chlorine is in group 7. If it's used 1 in bonding, it obviously needs 6 more electrons on each of the chlorine atoms. Notice I'm not bothering with circles with covalent, it's much easier to draw like this. And then I am not adding anything else because aluminium is in group 3. So once it's used its 3 electrons in bonding, that's it. So it's 1 mark for the bonds between the aluminium and chlorine and 1 for the extra lone pairs on the chlorines. Okay, mass spec question randomly coming up. It says, what is the formula with a mass of 267? So I know the only thing that's going into the mass spec is aluminium chloride, and I know the formula of aluminium chloride is AlCl3. So if I work out the MR, the molecular mass of AlCl3, it turns out that it's 133.5, and 133.5 happens to equal 267 over 2. So there are 2 lots of it, so therefore the formula of the whole molecule would be Al2Cl6. It is not correct to simply stick a 2 in front of AlCl3. 2 in front means there are 2 molecules, each containing 1 aluminium and 3 chlorine. This formula says there is 1 molecule that contains 2 aluminium atoms and 6 chlorine atoms. And so in the next bit we need to explain how that forms. So if it says use a diagram, and it says reference to the type of bonding, so those are clues. Definitely use a diagram. It's very hard to explain this in words without using the diagram to show what's going on. So we know that aluminium forms 3 bonds to the chlorine atoms, and we also know that leaves aluminium with a space in its outer shell. And so if we line up our aluminium chloride molecules, we can see that the chlorine on the left can donate a pair of electrons to the aluminium on the right and vice versa. So we have two dative covalent bonds formed between the aluminium trichloride molecules. And that is what we would say when it says reference to the type of bonding. We want to call it dative bond. You may call it coordinate bonding on your course depending on what you're studying. They mean the same thing. And I'm going to be clear, because it's a dative bond, I want to say from what to what. So it's from the chlorine is the one with the lone pairs, to the aluminium is the one with the space for electrons. And what that means is you've got two molecules joined together, but if you've drawn the diagram of the two molecules joined together, that's 2 marks on its own, so you don't really need to write anything extra other than describing the dative bond part. Two molecules joined together is also often known as a dimer, and you will hear that term used in other places, especially in mass spec. There are other molecules that can join together like this.